Algebra 1, Common Core, Unit 2, Section 4, Simplifying, Adding, and Subtracting Radical Expressions. Just to note that there is no video 2-3 in this chapter. So, simplifying radicals. We saw radical expressions when we were working with rational and irrational, and the big thing there was that if it was the square root of a square number, meaning the square root of 1, the square root of 4, square root of 9, square root of 16, 25, 36, 49, 64, so on, so on, so on. You know, those square numbers, let's actually make a list over here because we're going to need it today. So 1, 4, 9, 16, 25. And if you don't have these numbers, excuse me, if you don't have these numbers memorized, they're easy to produce. You know, since you're 1 times 1, 2 times 3, 3 times 3, 4 times 4, 5 times 5, which is the same thing as 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 64, 81, 100. So those are your first 10. You know, there's 121, 144, 169, 196, 225. I mean, the list goes on. I mean, you could do, 25 squared and 50 squared and stuff like that. But, the ones that you really need to be familiar with are you really 1 through 12, 1 through 13. But anyways, the square root of any of these is rational because the square root of 16 is just 4. It's the square root of a square. It's the, square root saying what times itself is this number. What times itself is 16. 4 times itself is 16. But any number besides these numbers, 2, 3, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20, 21, 22, 23, 24, all of those numbers are not square, so the square root of them is irrational. So something like the square root of 20 is irrational. But that doesn't mean it can't be simplified. It can be reduced. Now, sometimes irrational radicals can be reduced, sometimes they can't. Like if you have the square root of 7, that is irrational and it cannot be simplified. That's it. The square root of 20 can be, and the reason is because it has a square factor. It can be, what that means is 20 can be divided by one of or multiple of the numbers on this list. So if your rad number is not on the list but can be divided by one of these numbers, it can be reduced. So 20, for example, can be divided by 4. And so you want to think of the square root of 20 as the square root of 4 times 5. And then we can split it up into 2 radicals. Instead of rad 4 times 5, rad 4 and rad 5. And the one that has the square, which is 4, keep that one on the left, because that's the one that's going to reduce down to no longer be in the radical. The square root of 4 is 2. Rad 5 is irrational, not a square, it just stays rad 5. So the final answer is 2 rad 5. Now you could use your calculator not to simplify radicals, but you can use them to check it. If you do second square root, if I type in the square root of 20, first of all, this will also be a good method for confirming that it's irrational. I want to just double check. See, that certainly doesn't look like a rational answer there. But whatever this decimal is, my reduced form of 2 rad 5, which is what I think it simplifies down to, should be the exact same number. And so that's how I know I simplified it correctly. Let's say I made a mistake and thought the answer was 4 rad 5. Well, if I type that in and compare it to the original rad 20, I'm getting something different. So when you're simplifying radicals, the original radical and your simplified radical should have the same decimal in your calculator. All right, so that's simplifying radicals numbers. Let's do a few of those before we get to the variables. So rad 20, we already did. You want to think of that as the square root of 4 times the square root of 5, because when you multiply radicals, you multiply the numbers inside. I like to circle the one that's square and reduce it. The square root of 4 is 2, rad 5. Here's where you need to be careful, because a lot of people automatically start thinking, all right, numbers that multiply to 16, but 16 is on our list. 16 is a square number. So when you have the square root of a square, it's rational. The answer is just 4. Not rad 4, not 4 rad 4, just 4. A lot of people want to make the mistake of saying 4 rad 4, which doesn't make sense, or rad 4, which doesn't make sense. When it's rational, when it's square, you have no radical answer. 32 is always a good one to do because 32 is not square, it's not on the list, but it can be divided by a couple of things. 32 can be divided by 16 and 4. So which one should I use? Well, if we use 4, let's do that one first. So it's the square root of 4 and the square root of 8. So 4 8. That reduces down to be 2 rad 8. Because again, the square root of 4 can be simplified to 2. If I did the square root of, instead of 4 and 8, I could do the square roots of 16 and 2. And the square root of 16 is our rational one. That becomes 4 rad 2. So how come I don't get the same answer? 32 can be divided by 16. 16 times 2 is 32, and 4 times 8 is 32. The problem is sometimes when you simplify a radical, you got to take a look at the number that's left over, 8 in this case. Like here I was left over with rad 5. Rad 5 can't be reduced further because it can't be divided by any of these numbers, except for 1, but that doesn't do anything. Here, 8 can be reduced further. And if I take this 2 rad 8s, let me move this over to, where do I want to do this work? Shoot it over here real quick. So let me take that 2 rad 8 and ignore the 2 for a second and just keep it out front. Rad 8 can be split up to 4 times 2. And the square root of 4 is 2. Times the original 2 that was out front is going to produce an answer of 4 rad 2, which is what I got when I did 16 and 2. So the summary here is if your irrational radical has more than one square factor, if it could be divided by multiple numbers on this list, if you use the larger one, in this case 16 is larger than 4, if you use the larger square, then you will be able to simplify your radical in one shot. If you use the smaller one, 4 and 8, you will then have to reduce your radical in 2 rounds. Like we reduced it once to 2 rad 8, and then we reduced that to 4 rad 2. Okay, so if you have a choice between 2 squares, always go with the larger. All right, how about 3 rad 50? So, this was meant to be the first example where there's a number in front of a radical, but that kind of came up here. When you have a number in front of the radical, you just keep that number in the front and split up your radical into 2 radicals like you normally do. 50 is not square, but it can be simplified because it's divisible by 25, which is a square number, and 2. Reduce the radical. The square root of 25 is 5 rad 2. Now the number that was already out front, that gets multiplied by the new number that's coming out from your square radical. And so we'll end up with an answer of 15 rad 2. Simplified all the way. Again, I could type in 3 rad 50 and 15 rad 2. Let's see, 3 rad 50 and 15 rad 2. Whoops, didn't give me the 15. 15 rad 2. And I'm hoping for the same thing. If not, I know I made a mistake. All right, and here we have a negative 2 rad 18. The negative 2 stays out front. 18 can be divided by 9, which is a square, and 2. The square root of 9 is 3. Times that negative 2 in the front is going to give me a negative 6 rad 2. So you can have a negative in front of a radical. You just can't have a negative inside of a radical. It's actually called imaginary, which is something you'll learn about in Algebra 2. But for now, you can only have negative numbers on the outside, or coefficients of radicals, but not on the inside. Square root of a fraction is just split it up into the square root of the numerator and square root of the denominator, and treat them separately. Here, the square root of 4 is 2 because it's a square, and rad 5 can't be reduced, so we just leave it like that. All right, how about variables? So the rule for variables is different than the rule for regular numbers, as we would expect, like we saw in the last couple lessons with the exponent properties. And the issue is that we know that, like say, 5 squared equals 25. Therefore, the square root of 25 equals 5. These 3 little dots here in kind of like a triangle form, that's the symbol for therefore. So 5 squared is 25, therefore the square root of 25 is 5. I think you understand that. Well, x, let's say, to the third, the whole thing being squared. Remember, when an exponent's raised by an exponent, you multiply, so that would be x to the 6th. Therefore, the square root of x to the 6th is x to the 3rd. And what I'm saying here is that x to the 3rd times itself is x to the 6th because you actually multiply the exponents. So the square root, what times itself is x to the 6th, the answer is x to the 3rd. The very simple rule here is that when you have even exponents inside a square root, you just divide by 2. They are considered rational. Just like when you have the square root of 1, 4, 9, 16, they're considered rational. Well, even exponents are considered rational. Like the square root of x to the 8th is just x to the 4th. X to the 16th is x to the 8th. And just like we had the square root of 16 was 4, there was no radical because it's rational. Well, if you have an even exponent, there's no radical left over. So a rational radical has no radical when it's reduced. It's the odd exponents that you will end up with something rad something, something rad something, like you did for 20, 15, 18, 32. And the rule for odd exponents is you want to divide your exponent by 2, and the remainder remains inside. And because they're odd, the remainder should always be 1. So x to the 5th. If you divide 5 by 2, you get 2 with a remainder of 1. And what you, I mean, it's a little weird to think 5 divided by 2, but you could do 5 divided by 2 in your calculator. And the first number, 2, is how many exponents come out. The 0.5 is just telling you that you're going to have to leave 1 inside. So whatever your odd exponent is, divided by 2, the number out front, that's how many come out. The 0.5 tells you got to leave 1 inside. Like y to the 9th, or x to the 9th here. If I divide it by 2, I get 4, and 1 stays inside. So again, you could take your calculator and do 9 divided by 2, and it's going to be 4.5. So 4 come out, 1 stays inside. Okay. All right. You're not going to see a lot of stuff with variables. It's going to be mostly numbers for you guys this year. All right, adding and subtracting radicals is just like adding and subtracting everything else. You need like terms. When it comes to fractions, we need common denominators. When it comes to variables, we need the same exponents, right? Like I can add 3x squared with 5x squared because they're like terms. That's going to be 8x squared then. You don't add the exponents. You only add the exponents if I were multiplying, then I'd add the exponents. But if I'm adding or subtracting, you keep the term what it is. If I had, 3x squared, plus 5x, I can't add them together. They're not like terms. The same thing goes for radicals. We already talked about how you can multiply radicals. Like this rad 4 times rad 5 is rad 20. You can multiply unlike radicals, just like you can multiply anything unlike. But adding and subtracting is always like term specific. And you keep the term. So just like if you add 5x plus 6x, the answer would be 11x. It's not 11x squared. I can't stress that enough. A lot of people want to start adding exponents here. That's when you multiply a common base, not when you add a common base. When you add like terms, you keep the term, just add the coefficients. Well, 5 rad 2 plus 6 rad 2 is 11 rad 2, not 11 rad 4. You do not add the numbers inside the radicals. You cannot add or subtract rad numbers. You can multiply and divide them, but you cannot add and subtract them. So you just add the numbers in the front, 5 and 6. Now this works because they are like radicals. They're both rad 2. Here, 5 rad 2 plus 5 rad 3, that's the answer. That cannot be combined. You can't add it to 10 rad, because rad 2 is different than rad 3. That's like saying 5x plus 5y. You cannot combine it. You need like radicals. So sometimes you just can't add them together. Now what about rad 20, rad 45? They're not like radicals. However, they can be reduced. See, rad 2, rad 3, they can't be reduced. But rad 20, we've already seen, reduces down to 2 rad 5 because it's 4 times 5. Rad 45, that's rad 9 times rad 5. 9 times 5 is 45, that being a square. So that simplifies down to be 3 rad 5. And now that they're in reduced form, they are like radicals, and I can add them together to be 5 rad 5. So sometimes when you see unlike radicals, they actually can be combined. You just have to reduce them first. All right, how about this one? 3 rad 18 minus rad 8. 3 rad 18, so that's going to be 3 rad 9 times 2 is 18. Square root of 9 is 3 times the 3 already out front is going to give me 9 rad 2. minus rad 8 is the square root of 4 times 2 is 8. Square root of 4 is 2, so that's 2 rad 2. They are now like radicals of rad 2's. 9 rad 2 minus 2 rad 2 is 7 rad 2. How are we on time? Wow, 15 minutes. Sorry, I'm talking long here. All right, we'll shut this off because this is pretty much now repetitive. This last one, what you'll see is 2 can combine and the third one can't. You can give these a try if you want. But this is simplifying radicals, and it's a lot to talk about, so this is probably our longest video, possibly of the year. See ya.